Okay, so the first thing we need to think about then, we encounter these. So the first question is it a basic? And if not, is there a composite function? So is one of these a basic?
The bottom.
The bottom one. So how do we know that?
The answer is just simply the same thing.
Yeah, it's just a basic. There's just an x. So this one is not a basic. It's really close to a basic, but it's not because it's got an x plus 2. So this one's a basic, so we won't do that one. This one is a reverse chain rule, U substitution, however you like to think about it. So the important part here is we're finding the derivative. So the derivative of this is 1. Do I have that?
Yes.
I always have that. So that means the antiderivative of this, then E is just itself, plus C. So that's easy. All right, so let's look at this one. Is this a basic? Yeah, no way. So when you start seeing lots of pieces and you know it's not a basic, the first thing you want to look for is, can I find a composite function? Because there's a good chance then that part of, that one of the pieces is the derivative of the inside. So is this a composite function? No, it's just a power. Is this a composite function? Yes. So here's your inside. Derivative is 3x squared. So do I have that? You have the important piece. You have the x squared. So do we want to do it? Shall we do it one way U substitution, one way not? How many U substitution people? No one's doing U substitution? Couple? Okay. All right, so I'll sketch out the U, but then we'll also do it the other way. My thought is I have the variable part. You have to have that or you can't do the integral. Or we can't in this class. So I'm missing this. So if you're missing that, stick it in, which is multiplying it in, divide it back out, because you can't change the problem. So this right here, I just multiplied by a created value of 1. Now, once you've done that, this piece right here, if you want to, don't actually cross it off, because it really is still there. But remember, when we're doing chain rule, the derivative of the inside has to be sitting there. So once it's there in its entirety, you have taken care of the inside. All done. Don't need to even think about it anymore. So now you just think about the outside. The antiderivative of an E is itself. And then, on top of that, I would probably write it first, the 1/3 out front carries through. When you multiply, that carries through. So this is a perfectly fine thing to do. Don't actually cross it off because it really is still there. But once this is there in its entirety, you have completed everything you need to do with the inside function. And so you can ignore it from then on. Okay, so these are ones where you don't have, what am I trying to say? Fractions. So here are two more. X over the square root of x squared plus 3. And x over x squared plus 3. What's the question we need to ask when we encounter a fraction?
Is it a ln?
Is it a ln? That's your very first question. Is it a ln? And in order to be a ln, the entire derivative of the denominator must be in the top. So we're looking for this, du over u. The derivative of the bottom is in the top. What's the entire derivative of this? Is it going to be fairly complicated?
Yes.
Yeah, because this is really x squared plus 1 to the 1/2, so that's going to be complicated. So the whole derivative of the denominator is not in the top. So if it's not a ln, then what is it?
It's a power.
It's a power. And so I need to rewrite this in power form. Minus 1/2. The half comes from the square root, the minus comes from the denominator. And then this one, what about this one? Is this a ln or a power?
The derivative is x.
Well, the derivative of this is
2x.
2x, so yes, we
Oh,
mostly
2x,
have
sorry.
it, right? So we can put in the 2, and let's do this one U substitution, just for the U substitution folks. So this one, if I'm trying to simplify things, I'm going to let the denominator equal u. Because that's going to simplify things. The problem is that the denominator is a mess. And that means du is the derivative of that 2x dx. So what do I have? I have x dx. I have this much. So my recommendation is solve this equation for the piece you have. You have x dx, so write x dx, and then divide both sides by 2. So I'll have 1/2 du. So that means I know exactly this piece right here becomes u, and this piece becomes 1/2 du. So altogether then I would have, I'm going to stick the 1/2 out front, du over u. So 1/2 ln u. That's okay. And then put back in your x's. Do we need to do this one? Or do you want to move on to some other things? Do we need to do the power? So you change the course of history right now. Yes or no? Yes, we want to do it, or because I just want to make sure we save time to get to everything. Okay, yes, we will do that. Okay. In fact, why don't you guys do this one, and then let's check back. So go ahead and work on solving this one. So again, it's not a basic, so we're looking for a composite function. So identify the inside function. Take a quick go at that one.
Can we get the lights back on?
In the back, yes.
That'd be great.
Actually, yes.
Or does that kind of affect the camera?
Well, it's not great on the camera, but no, it's okay. Sometimes it is and sometimes it's not. You can never really tell. It depends on how much light's coming in from outside. So I think this would be a perfectly reasonable test type question. This is, to me, this is a straightforward one. So it's just better keeping track of all your pieces. How many people have answers? Okay, let's start looking at it. Okay, so it's clearly not a basic. I do see a composite function, so I'm going to find this derivative. Do I have it? The it part that's most important is this. Yes, this is missing. So I'm going to put it in and take it back out. Now this piece is the entire derivative of the inside. So per the chain rule, the inside is taken care of. I'm all done with that. So now I just need to look at the outside. The outside is this piece. So that means I'm going to have this, raise it by 1, and then divide by. I can divide by 1/2 or multiply by the reciprocal. Everyone agree? So I'm going to multiply by the reciprocal, and then I have the 1/2 from the very beginning. So the 1/2 carries through. That's this piece. I took care of the outside function, raise the power, divide by. Now I can go ahead and plug the inside back in. Let's see. Clean it up. 1/2 times 2 is 1. Go ahead and, might as well put it back in square roots. We like to, our brains, I think, consider this better when we have a square root sign, but we have to write it this way in order to do the power rule. So usually we write it that way and then come back out. So I would get square root of x squared plus 3 plus c. How can you check your work? Yeah, if I take the derivative of this, I should get back to this. So that's what, you can always check your work for those. Okay, so let's look at another set. There are different ways to say find the antiderivative. So I could say find y given some dy dx, whatever it is, right? It says I have the derivative, find y. So if I have the derivative, what process do I need to go through to find y? Antiderivative. I'm going back up to the antiderivative. And thinking about going up is a good way for powers. You're going back up to the original function, so that helps remind you to bump the exponent up. I could write this. That also means find the antiderivative. That's an instruction. I could write find total revenue if R prime of X, the marginal revenue, is 100 minus, I don't know why I wrote 1X, but I didn't. Because again, what am I trying to do? I know the derivative. I'm going back to the original. So these are all different ways to say find the antiderivative. If you have started with, so let's say you started with dy dx equals x squared. If it helps you, go ahead and write out, this is the instruction I think we're most familiar with that says do the antiderivative. So write yourself your instructions. If you want to find y, say y is equal to the antiderivative of x squared. Go ahead and write it that way, and then this becomes a really easy math problem. Then you know that part. So feel free to write more, not less. And to take out words and write math symbols. I tend to think better that way, I think. Okay. And then we need to talk about whether we find plus c or not. So let's look at a couple of those examples. Okay, so if I say find y, dude, such that, anybody seen that before? I used to do that substitution all the time. And anybody know the Spanish word for according to, which is a lot to write? So I used to write that all the time in my history notes. According to so-and-so, I'd write good, because it's shorter. So why not, right? I mean, why not? We all have our little shortcuts, right?
Yeah.
So, okay. Does it have an accent? No.
No.
I can't remember. It's been a while. Okay, so such that dy dx equals x squared and f of 1 equals 4. Okay, so when I do this, what is the first process I'm trying to do? I know the derivative and I want to find y. So what is my process? Antiderivative. So go ahead and write yourself some instructions. So this is an easy one. 1/3 x cubed plus c. Is this where I leave it? No, because I have enough information to find that c. So let's remember what this is. This value is your x value. This value is your y value. So go ahead and put in y. Y equals 4. 1/3 times 1 cubed plus c, so that's 1/3. 4 minus 1/3, 11/3. Are we done? No, because I've got y and I've got c, but I haven't put them together. So the final answer is when you're done. 1/3 x cubed plus 11/3. So just remember to write your final answer. All right, what about this one? Go ahead and try that one. I know it's got A's and B's, but that's okay.
So you just made that one up, or is that on the paper?
I think it's on the paper. It's, yeah, under to see or not to see. Really? Any
So-
smiles? Early in the morning, no?
Why are you contemplating suicide at 8:30 in the morning?
What?
You lost me on that one.
To be or not to be, it's all about suicide.
Yeah, but I didn't. I'm to see or not to see, so I'm okay.
Why are you contemplating, I guess, blindness? Yeah.
I'm-
That's
I'm-
even worse, like,
I'm contemplating jokes.
that's not even existential at that point. That's not even
All
meta.
right, all right,
like,
all
that's
right, all right,
just
all right. All
throwing
right.
acid in your own face.
Okay, so.
It's a bad idea. Go with C.
Oh my goodness. Just, yes. Will there be a C here
Yeah.
when you're done?
Yes.
No.
No.
Yeah, the
No, because you get paid.
Oh.
I don't care what you call it.
So let's talk about this one. This is an important thing. So one thing I've been seeing on assignments a lot, when you do the antiderivative, this comes off. This is your instruction to do the antiderivative. So once you have done it, you don't write that anymore. So the antiderivative is 1/3 x cubed, and then this becomes an evaluation bar on the other side. When you evaluate, you always evaluate top minus bottom. So we can just plug in. It's a and b, and that's a little bit strange, but okay. In the back of the book, they would probably factor out that 1/3. You could factor out that 1/3 in the very beginning if you wanted to. You could factor it out here, and then just multiply everything, the a squared, b squared, b cubed minus a cubed. All right, and then let's look at this last one. Find the total cost function. Work on that one. I'll write it up while you guys get started. Find the total cost function if the marginal cost function c prime of x is, wow, 3. And then I want to talk a little bit about word problem language. So this one should be pretty easy. So if I know this is 3x plus c. This c and this c are different. That's the cost function, capital C, that's just a lowercase c. Fixed cost. I could know that this is automatically my fixed cost, right? And just drop in the 2,000. Let's talk about what that means, though. Let's write it in some math language, because this does not work when you have exponentials. If you had an exponential, you couldn't just stick that in as 2,000. So what do fixed costs really mean? What that means is the cost when I have made 0 of them is 2,000. So the thing here is that this is your x and this is your c. So here you're going to put in 2,000. 3 times here you're going to put in 0 plus c. So of course we get c is 2,000. We know that. We knew that already. But this process is what you're going to want to use when you have something that's more complicated than a polynomial. So if you have an exponential, because e to the 0 is not 0. E to the 0 is 1. So sometimes that drops right in, but other times it doesn't. So just remember, this is really the process that you're doing. Importantly, I would not write c of 0 over here. Go ahead and put in the value for c of 0, it's 2,000. And then put in the value for x at 0. Go ahead and put those in. So what are some other ways? So fixed cost is one thing. What's another way to say that? If I said the initial cost outlay is, or if you were doing sales, the initial sales were 0. Initial means t equals 0 or x equals 0. That's, or you might say when 1,000 are produced, the total cost is. And that would be c of 1,000 is. So there are different ways to give this information. I recommend trying to get to a form like that, because once you can write it like that, then it becomes pretty easy to plug it. Okay. All right, so now let's look at area. This is what I really want to spend a lot of time on. So let's talk about area between two curves. And in particular, I want to review a little bit more about making sure you guys can sketch. You can use your calculators. People don't always use their calculators correctly, so I actually have more confidence in hand sketches than calculator sketches. So remember, we have two kinds of problems. We have area between some curve and the x-axis. That's one type. And then we also have area between two different curves. Okay, so let's look at the first one. And these are ones where we're just going to set them up. We'll sketch them and set up the integral, and you guys can finish that, that part later. So here is one. Actually, can we start with the other one first? Let's start with the minus first. Let's start with that one first. Okay, so when you're sketching this, this is what I recommend for your sketches. I recommend that you find the shape, the y-intercept, any x-intercepts, and any intersection points if you have that scenario. That's really all you need. It doesn't need to be any prettier than that. Okay, so figure out the shape. Y-intercept's always a breeze because you put in x equals 0. It may or may not have x-intercept, right? You could have, say, a parabola that's entirely above or entirely below the x-axis. So x-intercepts, just be aware you may not always have them. And then intersection points. So here, what shape is this? Parabola. And the y-intercept is? -4. Put in 0, so -4. So I know I have a point down here. And then I need x-intercept. So how do I find those?
Solve for.
Set it equal to x squared minus 4 equals 0. If there's no middle term, you do not have to factor. Right? If there's no middle term, you don't have to. You can just go straight to x squared equals 4 plus and minus 2. So I know I've got a point here and a point here. Okay, so then you just, I'm going to bless you, but I don't know that that's the right sound. Right? Sound, I don't know.
Just look at me and point and go, that was rude.
All right, we're all getting a little punchy. Okay, so I have this. So now I'm going to take this, and I think drawing in dotted vertical lines, much like you do an asymptote, is a great idea because it helps kind of show you where everything is. So here's 1. And so this is 2. I'm going to draw this a little, make it a little more like that. Here's 3. So the area that you want is between these two lines and between the curve and the x-axis. So if it helps you to think in arrows, you can do that. Just remember that you are only looking in here, and then you're only looking between the two curves. So we're looking at this area here and this area here. Remember, area is always positive, but integrals can be negative. So this part down here, if I were just to do the integral from 0 to 2, it would be positive or negative?
Negative.
Negative, because it's all below the axis. And this one would be positive. So there are 2 ways to do this problem. One way is to break them into 2 separate areas, essentially. You've got this one is the first one and the second one. So the first area, and you can just kind of tag them all together. This will be the first area. It will be from 0 to 2 of your function. But what do we know? We know that that's going to be a negative value. This will be negative, and area is positive. So anything that's under the x-axis, we just put a negative sign on front to flip the sign. And then I can keep going. So I've gone all the way to 2. I need to keep going. Now I go from 2 to 3. Same curve. It has a plus sign because its area is already, the integral is already positive. So I don't need to mess with the sign. And then you can just compute. So this is one way to do this problem. So I probably should have started with the other one first. Okay, so the second way to do this problem is to consider it to, we'll come back to the second way. We'll come back to the second way. So let's leave this one here. Now let's look at the second example, which is this with a plus sign. All right, so what's the shape? Parabola. And what's the y-intercept? 4. What are the x-intercepts?
There are 2.
There aren't any. And how would you know? What had to do the work? You set that equal to 0, you're going to get x squared equals -4. Can't take the square root of a negative number, so this gives you no answer. And that makes sense because this is a parabola opening up, so it's going to look like that. It does not go through the x-axis. The other way that you can tell is to do, so let's say you had something with a middle term. So this is a totally different example, totally different. Let's say you had this. And you're not sure if it factors or not. How can you tell? What's one thing you can do that will always let you know?
Take the discriminator or something?
Exactly. B squared minus 4AC. Remember, that's the inside of the square root in the quadratic formula. A is the number on the x squared, so A, B, C. So this would be 4 minus 4 times 1 times 3, -8. Can't take the square root of a negative number, so this does not factor. That means then that it's either entirely above the axis or entirely below the axis, one or the other. Okay? All right, so we've got this. So now so again, dot in the interval of interest. So we want to be between here and here. between the curve and the x-axis. How many pieces of area do I have then? Just one. There's just this big piece here. So I can just do the integral. The area is the integral from what? 0 to 3 of the function. Done. So it's important that you sketch. So again, sketching, figure out the shape, the y-intercept, that's a breeze. Figure out x-intercepts if you have them, and then you can have your sketch. I'm going to come back to that first one. Let's hop over to area between two curves, because this is where we need to add intersection points. Okay, so remember, area between two curves, the way we're looking at doing this one is upper minus lower. How do you know which one's the upper and which one's the lower? You need to do a sketch. You need to know where they intersect, because that's where they're going to flip places. Maybe, probably, but not always. All right, so let's look at this one. We have f of x equals x squared plus 3, and g of x equals negative 2x from 0 to 2. I could also have written this another way. I could give you these lines. I could say bounded by f and g and x equals 0 and x equals 2. I could write it that way, and that would just be essentially 4 different lines that would make one piece together. Okay, so what's the first thing we want to do here?
Find the intersection.
Yeah, we need to sketch these. So we need to sketch each one, and we need to know where they intersect. So I recommend kind of finding this information first, so that when you do your sketch, you get the right sketch the first time. All right, so why don't you guys get started on that? So we need, for each of these, the shape, the y-intercept, the x-intercepts, and then where they intersect. Let's start with that.